Okay. Next is anything else from week 3 before I write correlation?
Measures of dispersion, range, interquartile range, standard deviation.
That would cover the whole week 3 in some sense, right? Do you have any specific doubt in specific thing?
Outliers.
Outliers, okay. Okay, yeah, outliers we can focus on. Yeah. Outliers won't be the part of your quizzes because it's an additional topic which we generally cover. So we add it in graded assignment, but in general it won't be the part of your quizzes. Okay.
Okay, then we can skip this.
Okay. Any other?
Will we have questions based upon Google Sheets?
No. Google Sheet is just for your practice and just to make you aware of tools. It won't be the part of quizzes.
Okay, sir. Thank you.
Yeah. Which thing?
Covariance and correlation.
Correlation. Okay. Okay. Are you reading out all the topics of week 3 and 4, or these are the topics where you're struggling the most?
Sir, actually, week 3 and week 4 is comparatively tough as compared to week 1 and week 2 because week 1 and the topics in the week 1 and week 2 we have at least studied in our 10th or 9th, but the week 3 and week 4 are entirely different, sir.
Okay. 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 Correlation. Okay. So while covering correlation, we will also put some focus on covariance also. Okay. Have you seen the weekly revision session which we did earlier for each of week 1, 2, 3, and 4?
Yes, sir.
Yes, I think for complete week 3 and 4 revision, I think you can also refer those sessions. Okay. Anything else?
So
Sir,
interquartile
when
So
to
range.
can
use
you also
sample and population? Confused in that.
When to use sample or population? It will be mentioned in the question as a part of stats 1 course, but later on you
Sir, by
will learn
default,
when to
what we
use.
have to use?
That won't be by default in this coursework. You will learn when to use which one.
Sir,
Okay,
biserial
sir.
relation.
Okay.
Pardon me, sir. When the session started, sir?
We just started. We are just noting down the topics which we need to discuss today.
Okay, thank you, sir.
Okay. Uh, okay. Okay. I think that's all. Anything else that I should add it in?
Sir, someone saying percentile.
Percentile. Okay.
Yes.
Okay, I'll do
And
that too.
interquartile range also.
Hmm. Okay. So yeah, percentile and interquartile range we have added our tutorial on in week 3 content. You can refer that over there. Okay. We'll just write it
Just a
separately.
short note on relative frequency and column relative frequency. Just like sort of definition and understanding.
Okay, where are you struggling in that? Have you seen the lectures? Have you seen the revision session and solve questions? Where are you struggling in row relative and column relative frequency?
It's confusing, sir. Actually, I have written all
What's
the notes and stuff. It's still just a short note. It means just a sort of revision, sir.
okay?
So percentile and median.
Okay, yeah. So percentiles and IQR we have added it in the tutorials of.
So no, so difference between percentile and median.
You can check the tutorial. We have linked all those meet. There is no as such difference. 50th percentile is same as median. So we have added that tutorial video. You can
But
refer.
some answer was different if we calculate the median and the 50th percentile.
No, it won't be the difference. Will be the same. if you go by if you don't use Google method. Okay, yeah, it would be the same.
Sir, 5 number summary.
5-number summary. Okay. Okay, I think someone is making a lot of chaos in between. I should remove it here. Okay, I think percentiles IQR we have written. Okay, 5-number summary, right? 5-number summary you can do.
Yes, sir. Yes, sir.
5-number summary. Okay. Okay, so we will just, I think, start. I will add the topics later on. Let's start with these first. Okay. Okay, so area principle. Okay, so okay, I will like previous session. We will go by examples and try to understand the basic difference. Okay, suppose you have a categorical variable. Okay, and it can take labels A and labels B. Label A has the frequency of, let's say, 2, and label B has a frequency of 3, right?
Right, sir.
So how would you plot it? So in general, the plotting should be like this, right? That this is my marker 0, 1, 2, and 3, right? A is over here and B is over here, right? That's the correct plotting, right?
Right, sir.
And one thing to note down over here is uh, this is one, these are same, right? These are 1 unit. This is 1 unit, right? We keep it
Right,
same and let's say it's 1 unit. Okay.
right, sir. Right.
And this is 2 units, right? So what's the area of this bar? This bar area would be 1 times 2, which denotes that its frequency is 2. Okay.
Okay, sir. Okay.
Here also the base, like you can say breadth is same, right? It's again 1 unit, but height is now 3 units. So the area of this bar is 1 times 3, which denotes that the frequency of B is 3, right?
Right, sir.
Now suppose for some reason you want to show that A is greater than B, that the frequency of A is more than B. So one way we can do that is, I will plot it like this. So again, it's 1 unit for A over here, but for B, I will make it like this. Now what happens is it's again 1 unit and the height is 2, right? So frequency is 2, right? Here what we did is we make the breadth 3 units, height as 1 unit is show that B is smaller, and we represent that it is, we are showing the correct information, but at the first sight you will be able to interpret that A is greater than B in some sense, right? So that's how we, like, area principle is violated to uh, mis- mislead your audience by showing such plots.
Okay, okay, sir. Got it. And also at times, sir, the y-axis doesn't begin with the zero variable. At times, it begins with either of the integers, like
In that
one,
case,
two.
it's missing baseline.
Acha, हाँ, missing baseline. Okay,
Missing
sir.
baseline. Okay.
Okay, okay, sir. Got it. Thank you.
Okay. So area principle is okay. We're done. Next is measure of central tendency. Okay. So how many measures of central tendency do we have? We
Three,
started
sir.
in this
Three.
3.
Three,
Okay.
sir.
Mean, mode, and median.
Okay. I will keep it a bit here. Okay. So we studied about mean. We studied about
Median mode.
median and mode. Okay. What's the purpose of measure of central tendency? What's the basic need of measure of, like, what does it inside does it give you? Why do we need measure of central tendency?
It gives a central value of the total frequency.
To draw conclusion,
Okay,
It gives middle value.
yeah. So in some sense, suppose this is your data set. Okay. So we are looking for some point which balances it, right? Just like your seesaw, it's completely balanced, it's completely straight, right? It's neither bent on the left side or right side. It's that point which denotes the center or the middle point of your data set, which shows that that's the point where your complete data set or seesaw is balanced by this. Okay. So to find this, we have three measures: mean, median, and mode. But why do we need three measures? Why not only one? Because in some situation one might fail, and in other, like for each situation you have one. You have to select the better one. In some situation, mean would work better. In some situation, median would, and depending on your need, mode would also work fine, right? So let's say your data set is 1, 2, 3, 4, 5. What's the middle value? What's the average of these observations?
3, sir.
3.
3, right? So this is the okay. Now suppose now I change my data set and I add one observation 1000. Now what is the middle value as per mean? 2002, right?
Yes, sir.
Is 2002 really the middle value of this data set?
No, sir.
No, right?
No.
It's nowhere close to the center, right? So for such cases where we have such extreme observations, like my data set is even in single digit, and suddenly I'm getting one big value, right? So extreme values, whenever we kind of switch to the median now. So suppose the same data set, according to the median, what would be my middle observation?
Sir, the mean is 202, right?
202. Okay, still it's 202. Okay,
Yeah.
still it's not anywhere close to it is not a good middle value that I would
True.
require, right?
Median is 3.
Median is 3, and 3 is the actual middle value, right? It kind of balances my data. It's more accurate middle value as compared to 202, right?
Yes, sir.
So see, in for some data set, when we have 5 instead of 1000, mean was working good. We don't need other measures. But in case we have extreme values, my mean is not performing well and I switch to median, right? Okay. So what about mode? So suppose you are running a business, right? Let's suppose you have a showrooms of selling shoes, and you are interested in, uh, for you the major focus is on which shoe size sells the most, right?
Yes, sir. Shoe size and pattern.
Shoe size, yeah. So for shoe size, you might be interested. Let's suppose shoe size 7 is the most selling one, right? And you might have other shoe size over here, other shoe size over here, right? In some sense, if I plot it, then my plot would something be like this. 7 takes the peak, then 8, then size 9, let's say 10, 5, 6, 7, 8, 9, 10. So, which one is the middle, which is the most representative of middle observation in your data set over here?
It's 7.
7.
7 with
7.
highest
right?
frequency.
7.
So in such cases, mode do work better than mean and median, right? So depending on our need, that like here our need was something to focus on our business, expanding our sales. We needed to know where the demand peaks. So that's the measure of central tendency for us in this scenario, which can be computed by mode. And mean and median might not give me a better idea on it. While in case of extreme observation, median can give me the best, possibly the best measure of central tendency. While in general, mostly mean will do, but due to some restrictions, it might not perform well in all the cases, right? So these are the three measure of central tendency which we use as per our need and necessity. Any doubt in this?
Clear, sir. No problem.
Okay. Measure of dispersion. Okay, I will expand on this same question only. Suppose we have three data set. Okay, so data set one is the one we used earlier, 1, 2, 3, 4, 5. Data set 2 is, let's say, we 3 here, and I got 13. Okay, and my third data set is, let's say, 50. We keep 3 here. Okay, and other would be, let's say, I need to make it. Okay, what's the mean and median for the first data set?
Mean is 3, median is also 3.
Yeah, so in some sense, measure of central tendency is 3, right?
Yes, sir.
What about second data set?
Again, it will be 3, sir.
Again, it will be 3, okay. And what about third data set?
Again, same.
Again.
Again, it will be same, sir.
Again, same, okay, again 3. But so what's the difference between the three data set? Like for all, we have the middle value as 3, but what's the basic difference between the three
Because
data set?
So
we
mode
have
is
different
different.
values and we have negative values as well.
Okay, let me, okay, suppose I have plotted, right? So this is my middle value. This is 2, 1, 4, and 5. Okay, so here my line would be a bit bigger. If we go till 13, minus 10, and 3 would be somewhat here, right? And here it would be, I think, the biggest one, right? Minus 50, 50, and 3 would be somewhat here, right? So if you notice carefully in the first case, all the values are very close to mean, right? In second case, it's kind of a bit more spread across the mean value as compared to the first case, right?
Yes, sir.
And in the third case, it's the even more spread, right? Largest spread among the three, right? And so despite we know that measure of central tendency is 3 for all the three data set, yet we don't know anything about how other values are behaving with respect to this, right?
Yes.
So to find this spread, the term which I'm using constantly, this spread. To find this spread, we have measure of dispersants, and we have many measures of dispersion. We again use it depending on our need. Many measure of dispersants are not part of this coursework. There are many more which you can discover, but a few to take care of is range. Range is simply minimum value minus, oh sorry, I just showed it reverse. Maximum value minus minimum value, right? And then we have standard deviation. Okay, before standard deviation, we do have variance, right? We have variance where you take the deviation of each observation from the mean, then square it and submit, right? And we divide it by n or n minus 1 depending on our uh,
Sample of population.
yeah, whether it's sample or population, right? So what's the problem with range? Why not range only? Why do we need variance?
Because of outliers, the range value may vary.
See, in the range, suppose you have 1000, suppose you have 10,000 observations in your data set, right? So you are trying to tell the spread of this data set on the basis of using only two observations, right? And
Yes,
it
sir.
is also possible that maximum or minimum could be the extreme values as well, right?
Yes, sir.
So range might not give you good idea on the actual spread, right? So that's why we like range is the crudest measure of dispersion. We like in I don't think in practical life you will ever use it. Variance in variance we make use of all the observations to find out, right? We make use of we are using each and every observation to find out this measure of spread or dispersion, right? So variance is obviously a better than the range, right?
So, sir, for
Yes.
this exam, we don't need to focus on correlation and covariance.
And covariance we will cover, right? We are currently focusing on measure of dispersants right now.
Okay, okay, sir.
Okay, next is standard deviation, right? Standard deviation, it's nothing but we take square root of variance. Why so?
Sample variance, square root of sample variance.
For the units, to represent them in units.
Make units
Hmm, right. Okay,
same
suppose
unit
my
as
data, yeah, my
observation.
data is in centimeters. Right? Let's say my data set is observed in centimeter. But what happens is variance does not tell me the spread in the actual observation in which data set is stored, right? So to do that, we just square root it and we get the measure of spread or dispersion in the actual measurement of unit which we have stored data in. So that's why standard deviation is obviously the most, I think, useful one which you would use. We have other mean deviation and all that. If you want, you can explore, but it won't be covered in this coursework for now. Okay. Any doubt in this measure of dispersants?
No, sir.
No, sir.
Okay. One thing to keep in mind is we just saw that if there is an extreme observation or extreme value, my mean gets affected a lot, right? Mean not good, right? And if you notice carefully, your variance and standard deviation also depends on mean, right? So in case of extreme values, your mean would not be good measure of standard tendency, and In case of such extreme values, your variance and standard deviation would also be affected a lot. So there are methods which we use to take care of these things, but you will cover that in further courses. But for now, remember that if case of extreme values, your measure of dispersion do get uh, destroyed a lot. They won't give you the actual or good measures. Okay. Any doubt in this, or is it clear?
It's clear, sir.
Okay. Next thing is coming
Can you take
to
an example and find out the variance?
find out the
Variance standard deviation with the help of an example. We just so that we can refresh what we have learned.
okay. Okay. Let's take the same data set we have. This is my observation 1, 2, 3, 4, 5, right? And what's the mean? Mean of these observations,
3.
right? And for variance, we need to compute this xi minus x bar. Like every observation subtracted from mean and square. So 1 minus 3 squared would be
4,
2 minus 3 squared would be 1,
1,
and 0, 1, and 4, right?
yes,
If I sum it all, I will get 10, right?
10,
So my numerator is 10. If you want to find population variance,
it's
we will
5,
divide it by 5, right?
5,
So we get the value 2. If you want to find the sampled variance, we
where it
divide
is
it
4.
by n minus 1, right? So 1 by 4 times 10, which is 2.5. One thing, yeah, to keep in mind again is your sample variance will always be greater than population variance. Okay. So in some question where you are given sample variance and you are asked to find the population variance, so you can just verify that the answer you are getting is definitely should be smaller than that of sample variance. Okay. Is this clear or any doubt in this?
Yes, sir.
Yes, sir.
Okay. Moving further, we have outliers. Okay. Okay, outliers, as I mentioned, it's just an additional portion. It won't be covered in the quiz part. It's beyond the scope. But we have added in the graded assignment just to make you aware of it. So about outliers. Okay, so again, I will give it some reference. We have added a tutorial in week 3 content. There's a tutorial on percentile, quartiles, and interquartile range. So any observation which is greater than third quartile plus 1.5 times IQR, or any observation that is less than first quartile minus 1.5 times IQR are referred to as outliers. Now, how to find IQR to third quartile and first quartile, you can refer to this lecture, this tutorial. We have added a tutorial on it. Okay.
Okay, okay, sir.
So, in the above explanation of dispersion and measure loss and tendency, I was choosing this term extreme values, extreme values. So those extreme values are nothing but outliers. Okay. Okay, moving. further, I think we are done with this. Okay, before going to week 4, I will stick to a bit week 3 content only. So I will move to 5-number summary before covering that correlation and point Bayes. Okay. So yeah, again 5-number summary. Okay, I think we can put it like this. Yeah. Okay, so 5-number summary is nothing but these are 5 number which completely represents your data set. So let's say this is my data set, let's say, right? So first number in the 5-number summary is the minimum value. Second number is the first quartile. First quartile is which like there are 25% of observations below first quartile and remaining 75 are greater than or equal to first quartile. And then we have second quartile. Second quartile is nothing but same as the median. Median definitely splits your data set into 2 parts. Then we have third quartile, which again has 75% of the observation below it and remaining 25 above it. And the fifth number is the maximum value of your data set. So these are the 5 numbers which we refer to as the 5-number summary. Okay. So next time anyone says 5-number summary, so these are the 5 numbers which summarizes your data set completely.
Okay, sir, got it. Thank you.
Okay. Yeah. Okay, moving. Any other thing from week 3?
Sir, I have a doubt in week 3
Yeah.
assignment 5, practice assignment.
Which practice assignment?
Sir, 5th practice assignment from week 3.
5th practice assignment. I think we only have 2, right?
Sir, the percentile one.
Okay, let me. Week 3, which one? Oh, activity question you are referring.
Yeah, AQ 3.5.
Okay, which question?
Sir, 4th and 8th and 9th.
4th, 8th, and 9. Okay. What is the value of 9th percentile? So how to compute percentile? Refer this tutorial, week 3 percentile and quartiles tutorial. You will be able to do it.
Okay.
Or
And sir,
you are
8th
struggling
one.
with anything else. Okay. 8th one is what is the approximate value of first quartile? Do you know how to read box plot?
Sir,
So again, we have this box plot tutorial which tells you this. Just to give you an idea, this lower point which you are seeing, right, where this line is starting in between this 0 and 5,
yes,
right?
sir.
This is the minimum value. The point where this rectangular box is starting, it's first quartile. The point where this box is ending is the third quartile. And the point where this line is ending is your maximum value. So approximate first quartile value is that point where this rectangular box is starting, right? It is somewhat close to 17 or 18, right?
Yes, sir.
So yeah, that would be, I think 19 is the better among all the given options. So I will go with 19 for that. Ninth question is what is IQR? How do you find IQR?
Maximum minus minimum.
No. IQR is third quartile minus first quartile.
Oh, yes, sir.
Okay, so first quartile value we know it's close to 19, right? Third quartile value we know it's close to 51, 52, right?
Yes, sir.
So 52 minus 19 would be something around 33, right? So we will go with this. Now, how do we know that this is first quartile, this is third quartile, this is min max? Again, we have this box plot tutorial where it will tell you how to read and interpret information from the given box plot.
Okay, sir. Thank you, sir.
Okay. Anything else from week 3? Anyone? Before I switch to week 4.
Yes, sir.
Sir, five number summary includes the minimum value also, right?
Yeah, minimum, maximum, and 3 quartiles we have.
Yes, sir. Sir, actually, I attended the quiz one's solution that you gave the other day. Still, I'm not convinced that change in minimum value will affect the five number summary.
Change in minimum value will not necessary, may change, right? It may change. Okay, let me give you a bit data set. Right? I will keep it short just to tell you the difference between it. Okay. Suppose this is my data set, right?
So
In
you are
this,
saying,
what is the minimum? Yeah. Okay.
so you
In
are
this
saying
data set,
Q2 and median are similar
yeah.
as you are showing in the above. Is
Yeah.
so you have given the example above.
Mhm. Which example you are referring to? Okay, I think there is some network issue. I will complete this thing. Okay, yeah. So, what is the minimum value in my first data set?
5, sir.
5.
5. What about second data set?
5.
5.
5. Okay. Later, we noted that one observation 5 is wrongly noted as 6, right? This is the question you are referring.
Exactly, sir.
So, instead of 2, I have 6 now,
So,
and instead of 5, I have 6 now, right?
Yes, sir.
What is the
Yes,
my
sir.
new minimum value in first data set?
6.
6.
In the second data set,
5.
5.
5. So, I cannot generalize my minimum value will always change. It may or may not change, right?
Okay.
So that was the correct option. That my first, the minimum value, if I am replacing 5 by 6, my 5 number summary may or may not change. It might not always be the
Depends
case.
on data set.
Okay,
Yeah.
sir.
Okay.
Okay, sir.
And
Thank you, sir.
if you compute other Q1, Q3, it will definitely remain the same. Okay.
yes,
Okay,
sir.
sir.
So I have one
Thank
doubt.
you, sir.
It's like similar sort of question. It was there in quiz one, sir, the
Okay.
qualifier exam. Yeah, it was written that we have added one observation 6 is wrongly noted as 5, I guess.
Yeah,
And
this is the question. Yeah.
yeah, sir. But when we saw the solutions, it was written in that the first 5 numbers won't change. The 6th observation was wrongly noted. One second, sir. I'm just open the file.
Okay.
One second, sir. Set question. Yes, sir. 5 number summary of the data set 5, 10, 15, 20, 25. Later, it is noted that one observation 6 is wrongly noted as 5. Then choose the correct options.
Hmm.
It was a 3-mark question, sir.
Okay, that might be second set. So one observation 6, one observation 5 is wrongly noted as, okay, one observation 6 is wrongly noted as 5, right?
Yes, sir.
So yeah, that's what
And
that is. Instead of 5, like it should be 6 actually, but we have noted down
yes,
5.
sir. Actually, we
Yeah.
all thought the same thing. Many of the students had the same problem, which I saw.
Mhm. Okay, problem in understanding the question statement you are saying, right?
This is not clear, sir, actually. Could you please pardon?
Okay, I think I will write the complete data set to elaborate it. Okay. Okay, can you tell me the 5-number summaries given? 5, 10, I think 15, 20, and 25, something like this.
Sir,
So
it is actually 5, 10, 15, 20, and 25.
yeah, these are the 5-number summaries, right?
Yeah,
It
yes.
means I have some data set which has minimum value as 5,
Yes,
first quartile as 10, second quartile as 15, third as 20, and maximum value as 25, right?
right, sir.
Okay, so now I will work with two data set. Okay, one is data set 1. So in data set 1, okay, so in data set 1, suppose you have 10 observations. Okay, and obviously, and let's say 5 occur 2 times. Okay, and you have other data set, let's say data set 2. And here also, let's say you have 10 observations and 5 occurred only one time, let's say. Okay,
Okay, sir.
okay, okay. So let me just write it down. Yeah, 5 is definitely your minimum value right here.
Yes, sir.
Yes, sir.
First quartile would be okay. First quartile would be which observation? Third observation, right?
Yes, sir.
So your third observation is 10, right? Your Q2 is average of fifth and sixth, right? So average of fifth and sixth observation is your 15, right? And Q3 is your eighth observation, right? Which is 20, and maximum value we know is 25. This is my complete data set 1. Okay.
Okay, sir.
Okay. Now for the second case, what happened is my 5 is minimum value.
Sir, one query. Sir, why have we written that 5 is occurring 2 times in the first data set? How are we deriving that?
We are just assuming that in first data set is, let's suppose it occurred 2 times, in
Okay,
second
okay,
it's
okay.
just an assumption, right? So first quartile would be again third observation 10. Second quartile would be again average of fifth and sixth observation, which is 15. Q3 is again the eighth observation, which is 20, and maximum remains 25, right? Now, if we start with first data set, okay. So I had this 5, 5 and remaining 8 observations, right? Now it is given that one observation 6 is wrongly noted as 5, right? It means instead of this 5, I should have 6, right? Rest remaining observations remain same, right?
Right, sir.
Okay. Is now in the correct data set, my minimum value is 5 again, right?
Yes, sir.
And third observation is not changed at all. So first quartile is also same, second quartile is also same, third quartile and maximum values are all same because no other observation is changed, right? But if you look at this data set, we had 5 and one time and we had 9 other observations, right?
Yes, sir.
Now it one observation 6 is wrongly noted as 5. It means in the correct data set I should have 6 and remaining 9 observations should be same, right?
Yes, sir.
Is my minimum value same now or is it changed?
Change, sir.
It's changed.
Changed. Okay. But my third observation would still be 10, right?
Yes, sir.
And Q2, Q3 maximum all would remain the same.
Yes, sir.
even if minimum value is changing. Remaining all numbers in 5-number summary are same. Right?
Yes, sir. Right.
So you can see from data set 1 and data set 2 that even if change of one observation, my minimum value is the one which may get affected depending on number of times we have it in our data set, right?
Yes, sir.
So your minimum value, your 5-number summary may remain the same and may not remain the same also, right? So that was what the question was asking. Will it always change? Will it always remain the same? It
Okay,
may
so
Yes.
both
change.
may happen.
Yeah, so it's may or may not
Okay.
answer, right? Is it clear now?
Yes, sir. Yes, sir. Very clear. Thank you so much.
Okay. Okay. Shall we move to week 4 now?
Yes, sir. Sir, in the
Yeah.
activity assessment, I have one doubt in 3.2 activity assessment. Question number
3.2. Okay.
so question number 1 and 6.
Question number 1 and question number 6. Okay. What is the approximate mean? Okay. How do you find mean for such data sets?
Yes, sir. I actually am not able to calculate.
Okay. So what we do is we take the middle value, right? So middle value of 60 and 70 is 65. Why we
Okay.
take the middle value? You can refer the week 3 revision session. We have discussed it in
Okay.
detail why we take only middle value. So
Okay.
65 is occurring 7 times, right?
Right.
70, middle value of 70 and 80 is 75. So 75 is occurring 5 times. Then
Okay.
85 is occurring 4 times and 95 is occurring 4 times. Now can
Okay.
you find the average of these 20 observations? Where
Yes.
7 of which are 65, 5 are 75, right?
Right. Sir. Right.
So that's what it is asking. And why
Oh,
we are taking only the middle value, refer to that session. Okay.
okay. Sir. Okay.
Question number 6, it's again the same thing.
Same thing. Okay. Okay. Okay.
Yeah, middle value is 15. 15 is occurring 20 times. Then 20 to 30 middle value is 25, which is also occurring 25 times, right?
Right. Sir. Right.
Yeah. Refer to that week 3 revision session. In the starting only we discussed it. Okay.
Answer 3 point activity 3.1 question number 2.
3.1. Okay. Question number 2. Okay. Cashback worth of 40 to 60. It is 6 times, right?
How are we deriving this, sir? Could you please guide?
Yeah, she got the cashback of 1 to 20 rupees 5 times, 20 to 40 10 times, 40 to 66 times, and 60 to 88 times, 80 to 100 6 times, right? That's what frequency means, right?
Right. Right.
So out of total, I think 15, 21. Out of 35 times, there are 6 times when she received cashback worth 40 to 60, right? So 6 over 35 times 100 would give you this percentage thing, right?
Okay. Okay.
Yeah.
So number 4 and number 5 of this only.
Number 4, okay. Number 4. Okay, how did you approach this one?
Sir, I took the third box like 410,
Okay.
but it is
Ge-
not the right
Yeah,
answer.
3 means 410 users have given the rating of 3, right?
Right.
210 have given the rating of 4.
Right.
Is rating of 4 greater than or equal to 3?
Less than 3.
Greater than. Is 4 greater
Greater
than
than 3.
or equal to 3?
So pardon, sorry.
Third, fourth.
Is okay. Is rating of 4 greater than or equal to rating of 3?
It's less actually, sir.
Someone is giving you a rating of 4 star. Is it greater than 3 or less than 3?
Greater than 3, sir.
Okay. Someone giving you a rating of 5 star. Is it greater than 3 or less than 3?
Greater than 3.
Greater than 3.
Greater than 3, right?
Right.
Yes.
So rating 3 4 and rating 5, these are all greater than or equal to 3, right?
Yes, 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 sir.
So you need to uh, count how
Add all
many
those.
users have, yeah, how many users have given you these ratings. So
Okay,
410 have
okay,
given 3, 210 have given 4, 94 have given 5,
okay.
right?
Okay, 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 okay. Got it, got it, got it.
Question number 5, class mark is just again the middle point of that interval. So middle point of 55 to 60 is 57.5.
Okay, 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 okay. Got it, sir, got it. Thank you, sir.
Okay, moving further,
Excuse me, sir.
yeah,
Sir, I have a small doubt regarding calculating the percentile. Sir, whenever we calculate the percentile, there comes two situations whether n into p is an integer or it's not an integer. So if I ask on the topic of that not an integer, when we calculate np, for example, n is 11 or p is 0.5, so we get as the product of n and p as 5.5. So
right.
should we keep it as 5 or should we consider it and round it off as the sixth observation?
You will always round it up to the greater one. So even if it's 5.1, you will still round it off to 6. It
Okay,
will,
so if
it
at
won't
all
come
I'm
down.
getting
Yeah.
8.1, or if
It,
I'm getting that point, then I will always consider the next number.
yeah, next one. Yeah.
Okay, thank you, sir. Thank you.
Okay. Yeah. Okay. Okay.
So adding constants to the mean, median, mode variation only.
Okay.
Adding a constant or multiplying constant.
What would be the effect according to you?
Yeah.
Yeah. How would adding a constant affect my mean?
For the actual mean, also we'd have to add the constant.
Yeah. Yeah. And why so?
Because each value is increased or changing with the constant. So final value should also be
Yeah. So
remain
for
same.
the complete derivation or conceptual understanding of that, again, you can refer that week 3 session. We derived it properly. Why is it? Okay. For
Right.
mean, median, and mode. Okay. Okay. Yeah. Coming back. Okay. Now going to week 4, I must say. Okay. So in week 4, is it only correlation and correlation and point by serial, or any other topic also? Okay. So we
Yes,
will
only
start.
those
Yeah.
topics are there.
Which one?
Yes, only, yeah, only those topics are there. Yeah, there is relative frequency also.
Relative frequency, row relative and column relative, right?
Yes, sir.
Okay. What's the trouble in that?
I'm confused, sir.
Okay. Yeah. Confused. Like, but okay. Let me give you a simple data set. Suppose I have two categorical. Okay. Yeah. Before that, why do we compute row relative and column relative frequency? What's the purpose? Why are we interested in computing that?
To understand whether the particular row value is affected by the total value or not, to understand the proportion.
Okay. Okay. Suppose you are launching a car. Okay. Let's suppose you are launching cars. So, and as a marketing team of that car company, you want to know which audience to focus. Okay. Let's suppose you have two types of car. One is sports car you are releasing, and one is, let's say, sedan you are releasing. Okay. And you have your observations on number of males and number of females interested in it. Okay. So let's say 90 males interested in the sports car, 10 in sedan, and female, let's say it's 20 and 80. I'm just taking up some random values. Okay. So how do we find role relative frequency? You know that?
Yes, sir. 90 by 100 for male sports car and 10 by 100 for male sedan car.
Yeah. So if I write if I write role relative frequency, it would be 0.90 here, 0.10 here, and it would be 0.20 and 0.80, right? So you can see that these role relative frequencies are not same, right? Like for a sports car, there are 90% of men interested in and only 20% of females interested in. While in sedan, this scenario kind of reverse. Only 10% males are interested and 80% of females are interested, right?
Yes, sir.
Yes, sir.
So as a marketing team, if you're launching a sports car, which company, part of population would you target the most? Like if you have to advertise, you will make your advertisement more focused on male audience, right?
Yes, sir.
Because they are the one who will be doing that, purchasing the sports
Like the
car more.
sports car. Yes, sir.
In case if you're
Yes.
launching a sedan, you will try to advertise in such a way that your female part of population gets attracted, right?
Yes, sir.
So you see that depending on car type, your target population is changing, right? So
Yes.
in some sense, there is a relation between gender and type of car, right? There is a
Yes.
relation between them, right?
Yes, sir.
Okay. Now suppose I modify this number. I will just write it by, let's say, red color now. This is 50, 50, 50 for all. But what's my row relative frequencies now?
It will be 0.50 for all.
0.50 for all. Now if you are launching sports car, which part of population would you target more?
Both.
Both.
Both, right? So there is
Yes,
no
sir.
difference depend here. It doesn't matter which type of car you are releasing. Your audience is remaining the same. There is no effect on of gender on the type of car in this case, right? No
Yes, sir.
relation is there because these relative frequencies are same. So that's column relative and row relative frequencies are way to find whether my two categorical variables are associated in some sense or not. Yeah, and that's how we find it. We
Okay,
saw
sir.
that in case of sports car, I will target male audience. In case of sedan, I will target female audience. In case of blue observation, while in case of red observation, it doesn't matter. You can target your all the population irrespective of gender, right? It's not at all affected. So that's the use of row relative and correlative. Any doubt in this?
No, sir. Thank you so much, sir.
No, sir.
Okay. Okay. This is about two categorical variables I mentioned. But about in case of two numerical variables?
Covariance, sir.
Yeah, covariance. Okay, yeah, we do have a covariance. What covariance do is it just basically sum up all the product of deviation from their respective means. Like if I have two variables x and y, I will subtract the first observation of x from its mean. I will subtract first observation of y from its mean and product it, and I will add up all of them. I will divide by n or n minus 1 depending on population and uh, sample. And it will give me some value, right? Let's suppose I got this value of, okay, suppose I compute it for two data set again. Data set 1 and data set 2. Okay. Suppose for first data set you got something 100. Suppose your x is in kgs and y is in meter, right? So your unit would be kg meter, right? And for data set 2, let's say it is gram and liter. Let's say it's in grams and it is in liter. Which data set is more in which data set your variables are more correlated to each other or more associated to each other?
First data set.
Why so? Why you think it's first data set or why you think it's the second data set?
So how to understand which one, I mean, which way to approach, to think, which will be relatable.
Relatable in some sense. Okay, in what sense you are saying it's relatable?
Like, as you asked, which is more correlated. So how will we?
No, no, I'm just asking which of these two values are greater or less. Can you compare these two values?
No, no, no.
No, sir, they are not with standard units, same
They
units.
are not in same units, right? So that's the reason covariance we usually don't give us a good. Like it give us the good, but we cannot compare for different
Okay.
data sets, right?
Mm.
So
So
therefore,
that's
we do correlation coefficient,
yeah, that's why correlation coefficient do comes in.
wherein
So
we square root all the deviations.
yeah, we divide it by that to keep the units. It's a unitless measure.
Okay.
It don't have any unit. Okay, and it lies between -1 to 1. So you can definitely compare the two. Okay. So how to find it? It's again the numerator part remains the same, but in denominator we divide it by this. Okay. So that's your correlation coefficient. So here now
Yes.
suppose your data set X is in kgs and Y is in meters, and so your denominator would also be kg meter, and the units will get cancelled out, right? So it would always be unitless measure.
So in the numerator part, so we are not squaring all the x and x mean. Sorry.
No, no, we are not squaring. We are not squaring it in covariance also, right?
Yes, yes.
In
Okay.
denominator we are squaring, but when we are taking the square root also to keep bring the units back as per
Okay.
requirement.
Okay. So you mentioned it always lies between -1 to 1. So how is it? Could you please elaborate?
Uh, okay, so I will not go much in deep in that, but if you want, you can read about this. We have Cauchy Schwarz inequality. It is again beyond the scope of this course. It will prove you that denominator is always greater than or equal to the numerator. Like you can see that it is nothing but product of AB, right?
Right, sir.
And this is individual product of AB. So it will show you that this is always the relation. So if you want, you can Google and check it. Okay. So that's why its value will never exceed 1 because your denominator will never be greater than the numerator. It can be same, but never greater than. Okay.
So it means numerator is greater than denominator.
No, numerator is always smaller than the denominator. Smaller than or equal to.
Okay.
Okay.
Okay, sir.
Okay. So now suppose again you have two data set, right? Let's just complete it. So you again have data set. Let's say data set 1 has correlation coefficient value of 0.56. Second data set have value of 0.65. Definitely they both don't have any units, right? Now you can say that data set 2 variables are more associated as compared to data set 1, right?
Yes,
Now
sir.
we are able to compare different results. So that's why correlation coefficient comes into play and covariance not used much. Correlation coefficient, okay, it's not the only correlation coefficient. In statistics, there are several also, but In most of the cases, you will be using this, and it's only the part of your coursework. But in general, we do have more correlation coefficients also. Okay. Okay. Any doubt in this correlation, anyone?
Yes, sir.
Yeah. Okay. Moving to last part, point by serial correlation coefficient. Okay. So by now we have discussed association between two categorical, association between two numerical. So point by serial tells you association between one categorical and one numerical variable. Okay. So let's say again you have some two variables. Suppose my first one is, I will keep it simple. Let's say it's gender, and second one is, let's say, marks scored in an exam. I will, let's say, it's out of 10 only to keep the data set simple. So that's a male, female, female, male. I will keep it. Six. Okay. Yeah. So here you want to find out if there is any effect on marks based on the gender. So what we do is, yeah, okay. So for part of this course, we assume that your categorical variable has only two labels, not more than two labels. Okay, only two labels. So here my two labels are M and F, right? Now, as per your convenience, you can make any label as 0 and any label as 1. So suppose I take female as 0 and male as 1. If you want, you can take male as 0 and female as 1. Okay. So, okay, I will just write down the formula. And so my formula is something like this, if I'm not wrong. Even. Okay. So we will go term by term. Okay. So y naught bar is mean of those values which are corresponded to the 0th label. So my 0th labels are these two, right?
Sir.
What are my numerical values corresponding to these 0th label?
8 and 6.
8 and 6. What's the mean of 8 and 6? It's 7, right?
Yes, sir.
7. Yes, sir.
My males are labeled as 1. What are the numerical values which are corresponding to 1? Like
5
first
and 7.
label 1.
5
And what's
and
the
7.
mean of the two?
6.
6.
6. So these two values we have computed, right? Okay.
Yes, sir.
Yes, sir.
Next is P naught. P naught is proportion of values which belong to 0th label. So how many values are there in total?
4.
4.
4. How many values belong to 0th label?
2.
2.
2. So what's the proportion?
2.
4 by 2.
4 by 2. Yeah.
Proportion always lies between 0 and 1. It's 2 by 4, right? Two values belong to 0th label of the 4, right?
Yes, sir.
Okay.
Again, two values belongs to label 1 of the total 4, right?
Yes, sir.
Yes, sir.
Now we are left with only one term, sigma. Sigma is nothing but population standard deviation of numerical variable.
Sir, it's always population standard deviation.
Okay, I will come to that. Let's just do it by this method now. Okay. So sigma is nothing but population standard deviation of numerical variable. So again, you can find the population standard deviation of these four observation, and you can plug in, you will get again this your R, point by serial correlation coefficient. It will again lies between 0, like -1 to 1. One thing to notice, suppose you have taken MS1 and FS0, you are getting the value of, let's say, 0.60, right? Now, suppose second person comes and they change the label. Instead of 1 for M, they are taking 0 for M and 1 for F. So the value they will get is exactly the negative of the value you are getting, because my y0 bar and y1 bar will be interchanged in that case, right? It will just, the sign will change.
Yes, sir.
So that's why they will get. So in exams, generally we always ask only for the absolute value. Absolute value means you need to input your answer irrespective of the sign. Like if you are getting minus 0.60, you still have to input 0.60. If you're getting plus 0.60, you again have to put only 0.60. Okay.
Okay, sir.
Yeah. Okay. So is do one question arises is, do we always take population standard deviation? So the answer is no. You can also work with sample standard deviation, but in that case, some of the values do change. So your y0 bar remains the same, y1 bar remains the same, p0 also remains the same, but your p1 gets changed. It becomes number of values which belongs to label 1 divided by total minus 1, and then
Yes,
you
sir.
take sample standard deviation. So it's the same thing, but I feel this method is a bit complicated, so you can directly stick to this first method and go ahead.
Okay, sir.
Okay. Okay,
So is that the formula to compute point by serial? Y0 minus Y1?
Yeah.
Okay.
I think that's it. Okay. Anything else from week 4?
So can you please slide that towards where you have written the point by serial? I just want to note down.
Okay, sure.
So we are subtracting Y0 minus Y1.
Yeah, mean.
And mean.
Yeah.
And what is the square root of P0, P1?
P0 is the proportion of values which belong to 0th label. P1 is the proportion of values which belong to first label.
Okay. Okay, sir. Yeah. Thank you.
Okay. Yeah.
So,
Yeah.
can you explain fitting a line?
Fitting a line. Okay. Fitting a line in, like, in what sense exactly?
Sir, association between.
Your voice is breaking. I think. Can you type it in the chat box?
Sir, we will have EMQ sort of questions in our quiz.
No, it will. No, it won't be in the reattempt qualifier. Okay.
Okay, sir.
Okay, I think someone was asking fitting a line, but voice was breaking. So fitting a line, we again have discussed in that week 4 revision session properly. You can go and check. We have discussed all the different patterns of that fitting a line, which can have. So you can go and check that. Okay. So when we fit a line, there could be have polynomial relationship, quadratic, cubic, linear, increasing, decreasing. We have discussed all that in that session, week 4 revision session. You can go and check. Okay. Okay. Anything else? Anyone?
Yes, sir.
Yeah.
How to interpret the numerical value of pointwise serial correlation coefficient?
How to interpret numeric values of?
Pointwise serial correlation coefficient.
Okay.
After
How you
calculating
do
the
you know
P0.
how to interpret value of correlation coefficient after computing it?
Yes, sir.
Yeah, it's the same for point by serial.
So somewhere it is written the range is 0 to 1. -1 to instead of -1 to 1.
The range of absolute. Absolute means without sign, right?
Absolute sign, na? Yeah, yeah.
It will be 0 to
Modulus
1.
value.
Yeah, it
0
would be
to
0
1.
to 1, right? Because absolute means only
That's
positive
okay.
values.
Yeah, and then what is what the if suppose that value is 0, that means both are independent or not related. What should be concluded?
Okay,
Suppose
whose
your
values
value
is
back
zero?
is 0.
Point by serial or correlation coefficient?
Point by serial. Suppose we
Point by
have the
serial.
same,
Okay, zero means yeah, they are not associated. Okay, not exactly
not
zero.
associated.
It
Yeah,
complete range of this,
complete
it
range
will
of
be
0 to
not associated. As
not
soon as you
associated.
touch,
That means,
yeah, no
yeah,
relation between the two.
we cannot call it both are independent. We call it
Yeah,
if
in
it's
that case,
not
you can
related.
both are independent. You can say.
Both are
You have,
independent.
in this case, you can say yeah. For point by serial, I'm talking.
Okay.
As soon as you touches 0.25, it becomes weakly associated.
Weakly associated. Then it is
Then as soon
that
as it touches
as
zero
the
point
value
0.5, it becomes moderately associated. And after that, it becomes
is strongly.
strongly associated.
Okay, sir. Thank you, sir.
Sir, can you provide us with notes of week 3 and week 4?
Notes of week 3 and week 4 are still under preparation. We will try to release it before your exam. Let's see if that possible. We will definitely provide you.
Okay, sir. Thank you so much, sir.
Okay, anything else or shall we close for today? One more
Sure.
session we will have where it will be complete open session of week 1 to 4. So whatever we have revised, do go practice and so try to solve. So in last session we can discuss like focus mainly on the problems, not on the concepts again.
Yes, sir. One question. In the
Yeah.
week 3 tutorial 5,
Okay.
it is mentioned sample mode as 3. Can you please guide what is sample mode and how are we deriving as 3?
Okay. Where it is, which part of the video?
Sir, it's
Sample
written.
mode is okay. It's sample mode is same as like sample mode and population mode are the same. So mode means the value which has the highest frequency.
Yeah.
So maximum frequency is of value 3, right?
Oh,
So
okay.
your
Okay.
mode is 3.
Okay. Got it. Sir. Got
Okay.
it. Thank you.
Yeah. Okay. Anyone? Anything else? Yeah.
Sir, mode is for only for categorical variable.
No, it's for numerical variable also, right? The
Numerical
question we
also.
just saw was of numerical variable.
Yes, sir. That was numerical. Mean is
If,
only for numerical, not for categorical.
yeah. Mode is the only thing which is for both numerical and categorical. Always.
Categorical.
Median,
Median is for
it
ordinal
depends if
variable.
categorical is ordinal. Yeah.
Ordinal.
Okay.
Right. Okay. Thank you.
Okay, I think that's all for today. See you again in the next session.
Any
Sir, I have a doubt, sir.
Yeah. Yeah, please ask.
Sir, practice assignment question number one second. Question number 4
Which
and
practice assignment?
3.3 actually, sorry. 3.3 question number 4 and 4 and number 6.
Activity 3.3, right? Question number 4.
Yeah.
Okay.
Activity 3.
The median of certain data set is 21. Now, each data set is incremented by 4 and then multiplied by 4. Okay. Suppose you have 5 observations in your data set.
Mm-hmm.
What would be the median?
The third one.
Third one, right? Now, each observation is incremented by 4. So your third one is also get incremented by 4, right?
Right, sir.
And it is still the median, right? Third observation, it
Right.
is still the third in ascending order and still the middle one, right?
Right, sir.
So now instead of 21, 25 is your median. Now each observation is multiplied by 4.
Right.
So instead of 25, your third observation becomes 100 and it's still on third position in ascending order, right?
Right.
So it's 100, right?
Oh, okay. So, but how have we assumed the numbers? Just like randomly or any?
Randomly, you can try with any random number. It will always work.
Okay.
Yeah. Similarly, you can try this also now, right?
Got it.
Okay.
Okay, thanks. Sir, can you explain the above stem and leaf question?
Stem and leaf. Okay, yeah, sure. Stem and leaf plot. What is the median of the edges? Okay, so how many observations are there? 20, right?
Yes, sir.
It is
Yes, sir.
already arranged in the ascending order, right?
Yes, sir.
So, but would median would be the, say, our n is even, right? So it would be the average of two middle observations,
Yes, sir.
which is the mean of 10th and 11th observation, right?
Yes, sir.
But is my 10th observation here? 71, right?
71.
11th one is,
73.
what's the average of the two?
144 divided
72.
by 2. 72.
72, right? Okay, that's the median, right?
Yes, sir.
So average of the two is 72. That's our median, right?
Okay, sir.
Okay.
Thank you, sir.
Okay, yeah, thank you. I think, is that all or anything else? Okay, I think that's all for today. Thank you, everyone. See you again in the next session.
Thank you so much, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.